Hello, everyone. This video is on Aditya L1 mission launched on September 2nd. So let's get started. Aditya L1 is a coronagraphy spacecraft to study the solar atmosphere, designed and developed by the Indian Space Research Organization, ISRO, and various other Indian research institutes. It will be inserted at about 1.5 million kilometers from Earth in a halo orbit around the L1 Lagrange point between the Earth and the Sun, where it will study the solar atmosphere, solar magnetic storms, and their impact on the environment around Earth. It is the first Indian mission dedicated to observing the Sun and was launched aboard a PSLV-XL launch vehicle at 11:50 HRs IST on September 2, 2023. Mission objectives. The major science objectives of the Aditya L1 mission are 1. Study of solar upper atmospheric, chromosphere, and corona dynamics. 2. Study of chromospheric and coronal heating. Physics of the partially ionized plasma, initiation of the coronal mass ejections, and flares. 3. Observe the in situ particle and plasma environment, providing data for the study of particle dynamics from the Sun. 4. Physics of the solar corona and its heating mechanism. 5. Diagnostics of the coronal and coronal loop plasma, temperature, velocity, and density. 6. Development, dynamics, and origin of CMEs. 7. Identify the sequence of processes that occur at multiple layers, chromosphere, base, and extended corona, that eventually leads to solar eruptive events. 8. Magnetic field topology and magnetic field measurements in the solar corona. 9. Drivers for space weather, origin, composition, and dynamics of solar wind. M. History of Aditya L1 mission. Aditya was conceptualized in January 2008 by the Advisory Committee for Space Research. It was initially envisaged as a small 400 kilo, 880 lb, LEO 800 kilometers satellite with a coronagraph to study the solar corona. An experimental budget of 3 crore INR was allocated for the financial year 2016-2017. The scope of the mission has since been expanded, and it is now planned to be a comprehensive solar and space environment observatory to be placed at Lagrange Point L1, so the mission was renamed Aditya L1. As of July 2019, the mission has an allocated cost of RSRs 78.53 crore excluding launch costs. Aditya L1 will be able to provide observations of Sun's photosphere, chromosphere, and corona. In addition, an instrument will study the solar energetic particles' flux reaching the L1 orbit, while a magnetometer payload will measure the variation in magnetic field strength at the halo orbit around L1. These payloads have to be placed outside the interference from the Earth's magnetic field and hence could not have been useful in the low Earth orbit as proposed on the original Aditya mission concept. One of the major unsolved issues in the field of solar physics is that the upper atmosphere of the Sun is 1,000,000 K, 1,000,000 degauss, 1,800,000 deg hot, whereas the lower atmosphere is just 6,000 K, 5,530 degree, 10,340 degrees. In addition, it is not understood how exactly the Sun's radiation affects the dynamics of the Earth's atmosphere on shorter as well as on longer time scale. The mission will obtain near-simultaneous images of the different layers of the Sun's atmosphere, which reveal the ways in which the energy may be channeled and transferred from one layer to another. Thus, the Aditya L1 mission will enable a comprehensive understanding of the dynamical processes of the Sun and address some of the outstanding problems in solar physics and heliophysics. The Aditya L1 mission holds the promise of significantly advancing our understanding of the Sun's behavior and its interactions with Earth and the space environment. The planned observations and data collection from this mission could lead to several groundbreaking discoveries and insights in the field of solar and heliophysics. 1. Coronal heating mechanism. One of the central puzzles in solar physics is the coronal heating problem. Why the Sun's corona is much hotter than its surface. Aditya L1's instruments, particularly the Solar Ultraviolet Imaging Telescope, SUIT, and the Visible Emission Line Coronagraph, VEL-C, will enable detailed studies of the corona's dynamics and composition. By closely examining the behavior of the corona, scientists hope to unravel the mechanisms responsible for heating this outer layer of the sun. 2. Space weather. Prediction. Understanding the sun's behavior is crucial for predicting space weather events, which can have significant impacts on Earth's technology and infrastructure. The mission's data will provide insights into the processes that lead to solar flares, coronal mass ejections, CMEs, and solar energetic particle, SEP events. These insights can contribute to more accurate forecasting of space weather phenomena and their potential effects on communication systems, satellites, and power grids. 3. Solar wind and magnetic field studies. Aditya L1's instruments like the Aditya Solar Wind Particle Experiment, ASPEX, and the magnetometer will offer a comprehensive view of the solar wind's properties and the interplanetary magnetic field. This data will help refine models of the solar wind's behavior and its interaction with Earth's magnetosphere, shedding light on the dynamics of this critical space environment. 4. Understanding Earth's climate. The sun's activity can influence Earth's climate over long time scales. Aditya L1's observations of near UV solar radiation and its impact on Earth's upper atmosphere can contribute to understanding how solar variability might affect Earth's climate patterns. This could provide valuable information for climate researchers seeking to differentiate between natural and anthropogenic factors driving climate change. 5. Comprehensive solar atmosphere. Imaging. The suite of instruments on Aditya L1 will provide multi-wavelength observations of the sun's atmosphere, from the photosphere to the corona. These simultaneous observations will allow scientists to trace the flow of energy and matter between different layers, offering insights into the complex processes that govern the sun's behavior. 6. Origin and dynamics of CMEs. Coronal mass ejections are powerful and potentially disruptive solar events. Aditya L1's observations of the initiation and evolution of CMEs will contribute to our understanding of their origins and behavior, potentially leading to improved models for predicting their occurrence and effects. Last topic is launch. The launch of Aditya L1 mission took place successfully on September 2nd at 11:50 a.m. IST. The spacecraft was injected into the intended orbit at about 12:54 p.m. IST. The first earthbound burn is planned to take place on September 3rd at around 11:45 IST. All topics regarding the Aditya L1 mission completed. If you like the video, then don't forget to subscribe. Your one subscribe motivate me to make more such videos. Thanks for watching. For more videos, check the playlist.